Okay. So just a bit of a recap. Basic compound interest questions. If you had a question that requires compounding of interest, the formula that we need to use is A equals P bracket 1 plus R to the power of N, where P is your principal, R is your rate, and N is your number of periods, the number of periods, or usually years, but it could be years, it could be half a year, it could be quarters, it could be months. So and A obviously is your total amount, including interest. So the amount including the interest. Okay. So it says find the value of each investment after it matures, which means at the end of the investment period. We'll do by V, because I think most of you guys get this. So A equals 7,000. It does say it's 9% per annum, which means per year, but it is compounded monthly. So that means it should be 1 plus 9% over 12 to the power of 3 years, but it can't work because it's got to be monthly. So 3 times 12. And then you just plug all that into your calculator and you should get an answer. Anyone have any questions for this? No. That makes sense. Good. Let's look at question. Let's look at question 3. Question 3 says a car initially worth 28,000 depreciates, which means not plussing, you got your minusing, at the rate of 24% per annum. Find out how much the car is worth after 1 year. So the car will be worth 28,000, 1 minus 24% to the power of 1. We can actually work that one out fairly quickly. 1 minus 24%. It is worth 21,280. How much value does the car lose during its 4th year? Okay, double line. How much value does the car lose during its 4th year? Anybody have a way of doing that one? So it doesn't say how much is the car worth in the 4th year. It's how much did it actually lose during its 4th year.
Wait, you know how like in the first one for I at the end you got like, for example, 21,280.
Yeah.
You say if we were like to find that, I would do like 28,000 minus that, but we just have to like find.
That's the logic.
4 years as well.
Correct. So how would you do the exact same thing for the 4th year? So you understand the logic, which is really good. So all you're going to do is go 28,000, 1 minus 24% to the power of 4. That's how much it's worth in the 4th year.
Mm-hmm.
Of course, minus 28,000 to the power of 3. That's how much it was worth in the 3rd year. You'll get a negative number, and the only reason why you get a negative is because that's how much you actually lost during the 3rd to the 4th year, which would be the 4th year. Does that make sense?
Yes.
Yep.
Do we understand why I chose as well 3 and 4, not 4 and 5? Because everybody would, I mean, most students would say, oh, during its 4th year, that means let's choose like 5 and then 4. Because the 4th year would be for like 4, 4.1, 4.2, 4.3.
Yeah.
Right? Yeah. So why didn't I choose 5 and 4? Or did I do it wrong? Any ideas?
I don't know.
Okay, Azra, any idea when something like how this works? If it's during this 4th year?
No.
No. Okay. Well, okay. Let's do an example of a baby. I mean, that's fairly straightforward, I think. If there was a baby and it was a newborn, right? let's say that it's a newborn and it's only a couple months old. So let's just say it's 2 months old. Isn't that technically, if it's a newborn and it's 2 months old, wouldn't you say that that is in the first year? So the first year would be from 0 to 1, not from 1 to 2. If they were now 1 year and like 3 months, let's just say 1 year and 3 months, well, now they're in their second year because they're going to go from 1 to 2. This was their first year, from 0 to 1. Does that make sense? And the only reason why this happens for you guys, usually when we're counting, we count from 1, right? We start from 1. But if you're doing like things like years and birthdays and stuff like that, we don't start from 1, we start from 0. And when you're starting from 0, you're gonna have that little bit of a mix up there. So if I'm 5 years and 6 months, technically I'm in my 6th year. Is that clear now?
Yeah.
So like, yeah, Alex, pretty much if it's during your 4th year, that means you're at your 3rd year to your 4th year. That's the logic there. Cool. All right, let's move on. If we don't have any questions, we'll move on and actually look at these superannuation questions. They take up about a page. So each one of these superannuation questions should take a decent amount of lines. So make sure you give yourself that. Before we start, does anyone actually understand what superannuation is? Has anyone heard of superannuation?
I've heard of that, but like I don't really know.
Do you know what context is? Like, what its purpose is? Do you know if it's a saving account, if it's a loan account, or do you know anything about it?
Not really.
Nothing?
Savings.
Fair enough. Alex? Elle?
Yeah, I think it's a saving. I'm not sure.
It is a savings, and do you know when it can be used, I guess?
When you retire?
Yeah, that's good. Anything else that we know?
Oh yeah, isn't it like a retirement sort of thing?
Yes,
like,
it is a
is it like when you like?
Yes, tell us.
I don't know. I forgot what I was gonna say.
That's funny.
It comes out of your wage or salary?
Yeah, something like that. It's like you put money aside.
You don't. It is automatic. So it's set up by your employer. They have to automatically take out. Right now it's about 9.5%. I think by the time you guys are going to be working and everything like that, it will creep up to about 12%. So they have to automatically take that out, 12% of your, let's call it your wage or your salary, and put it in a savings account until you retire, which is usually around above 65. Again, by the time you guys are going to be working, it is looking around the 70 to 75 because we're living longer. Any questions about that right now? So it's good from a, I guess, a long-term point of view, right? Right now, you can't access the money, so it is locked away. But yeah, that's pretty much what superannuation is. It's a savings account for when you pretty much retire because you can't work as much. You need to have a decent amount of saving to I guess purpose your life for the next 35, 40 years that you'll need care for. It is usually a percentage, but I think in this case most of it's going to be done as a whole number. So they're not going to give you an actual percentage. They're just going to say this is the amount that you're going to invest. Like I said, it's usually automatic, so your employer does it. In our case, we're going to assume that we are the ones that are going to be putting it in let's say every year or every month or every so often. Okay? And it's always the same amount in these cases until you get to some of the more complex ones where it says I might do 2,800 for the first 20 years of my career and then pump it up to 10,000 for the last 10 years. And then the series changes. Okay. As with a lot of, I guess, concepts for math, especially at year 11, year 12 level, I do them very differently to your school teachers. The way I would be doing my superannuation is a little bit different to the way you're going to get it taught at school. I like to do it this way because I think it makes the most sense for everybody. So the way I'm about to do it will be very different to the way your teachers will do it. From what I understand, your teachers go downwards, so they're going to go backwards. The way we're going to do it is we're going to go forward, so we're going to increase in value. Okay, I don't think there's any questions there, so let's start this and see how this works out, and then we might even do an example that you guys like, which would be any amount that you would like to invest and see how much it can grow to. Let's have a look at this. Question 1. An amount of $2,800 is invested in a superannuation fund at the start of each year for 35 years. The fund earns 9% per annum compounded annually. How much is the investment worth at the end of that time? Okay, these are all going to be geometric progressions. So all of superannuation and loan repayments are geometric progressions. They're not going to be APs. The formula we need for a geometric is usually going to be Sn, which equals to A 1 minus r to the power of n over 1 minus r, just so you know. So that's the formula that we're going to need when we get there. All right, so $2,800 is invested every year for 35 years, and it's at 9%. A1, my first year. My first year I would have put 2,800. That would have grown by 9%. And this would be the total amount I would have at the end of that year. Is that right?
Yes.
Alex, makes sense. I need girls. Does that completely make sense?
Yeah.
So I put 2,800 at the beginning of the year, and then at the end of the year, I would have had it at 2,800 times 1 plus 9%, whatever that would be. We're not interested in the answers. But what we want to do is not write this as 1 plus 9%. We do want to write that in a simplified version, which would be 1.09. Okay. Then we need to work out what A2 is. So this is always you're working out. Always you got to work out A1. Then you got to work out A2, and then you got to work out A3. A1 is the amount left at the end of the first year. A2 would be at the amount left at the end of the second year. Okay, Alex.
Yes.
So at the beginning of the first year, I put in 2,800, and then it grew for 9%, right?
Yeah.
Second year, what must I do? An amount of 2,800 is invested at the start of each year. So in the second year, what am I going to do first?
I'm gonna write like the end of the first line, like 2,800, like at
Yep.
1 point.
Yeah. I'm going to write that soon. But what happens at the beginning of the year? Just quickly. What must you do at the beginning of the year? You must put in another what?
2,800.
You're going to put another 2,800 on top of whatever happened in A1.
Oh, okay.
And then that whole amount is going to grow for how much?
9%.
Yeah, so again, multiplied by 1.09. Thank you. Girls, Azra, let's start with you. Does the logic of that make sense?
Yeah.
You're going to add 2,800 to the amount that you had left at the end of the first year, and then the total amount you're going to have is going to grow for 9%. So plus times by 1 plus R, which is 1.09. Okay, Stephanie, makes sense?
Yeah.
And obviously L.
Yeah, makes sense.
Beautiful. Then what you're meant to do is replace A1 for A1. So which is 2,800, whoops, 1.09 times by 1.09. And you guys, I promise you, this gets very, very repetitive very quickly. But you've just got to be patient with it and not be scared of all this math you're going to see. Okay, let me know if you have any issues there.
Why do we have to keep putting 1.09 again? Like, what do we have to keep timesing it?
The reason why you're multiplying is because if you put money in it, like think of a bank account, right? Yeah, you with me, Steph?
Yeah.
If you at the beginning of the first year you put 2,800, well, you're going to earn interest, aren't you?
Mm-hmm.
So that's going to grow by whatever this amount is. Then in the second year you put a little bit more money. You put 2,800, but then in the second year that whole amount is also going to grow again for another 9%.
Oh, okay.
And then what happens in your third year, and your fourth year, and your fifth year, and your sixth year, seventh year? Every year you put money in on top of the previous year, and then it's going to grow.
Yeah.
Pretty much this word, compounded annually.
Mm-hmm.
Good job. You guys, I'll be back in about a minute. Give me a second.
Are we supposed to do this all the way up to like 32? I'm gonna cry. I swear to God.
You make it into a geometric progression. So you think you like sub it into like the formula.
Okay.
Makes sense.
All right, I'm back. Do we have any questions for this before I move on? No? Okay.
No.
A3. L, what's going to happen in A3?
The same thing that we did.
So tell me. So in A3, at the beginning of the A3, you've got to put in how much?
2,800.
On top of?
8
And then that's going to grow for?
1.09.
Done. And then you're going to replace A2 for all of this thing, which will look like this. And then you're going to multiply all of that by 1.09. Make sense? You can see why people get scared of this very quickly. Steph, Alex, makes sense. Ezra.
Yeah.
Makes sense.
Let's see if the logic also makes, because believe me when I tell you, your teachers will not be doing superannuation the way I just did it. The reason why I personally teach it like this is because when we do loan repayments, I'm going to do the exact same math. But I also believe this makes more sense for most kids because, I mean, the logic is there. You're going to be putting money in, adding on top of what you had before, and then it grows. You put your money in on top of what you had before, and then it grows. And then if you look at the final answer, that even makes sense. The first one you put in, Alex, the very first one I put in here, if I'm in my 3rd year, how many years has it grown now?
2 times.
Well, yeah, technically, but let's just say if you you put it at the beginning of the year, let's just say that amount, and then you're at the end of the 3rd year. So technically it grew for 3 years.
Yeah.
And there it is. The second one you would have grown for 2 years. There it is. This last one, the last one that you just put in now, will only grow for that 1 year. 1, 2, 3. So the first one you put in went for 3 years. The second one you put in went for 2 years. The last one you just put in only goes for 1 year. Girls, does that make sense what I just said there as well?
Yeah.
Yeah.
Beautiful. Maybe now you guys can sit down with your parents and actually look into their finances and tell them, hey, this is how you do all this. So you got to calculate. All right. Now, let's answer the question. So you have to always, every single question, no matter what it says, even if it's broken up into parts, you must do A1, A2, A3. Then, from there, you can generalize. So, ... we're going to work out for 35 years. Now, obviously, we're not going to go and do this 35 times. So we have to work out a way to generalize this. And it's not that hard. So A35. Well, A35 is going to start with what? 2,800, 1.09 to the power of 1, plus 2,800, 1.09 to the power of 2, plus ... until 2,800, 1.09. The way you do it now, you look at this. This was a 3. This was a 3. Which means if this is a 35, my last one here must also be a 35. And look, I've got a series happening. ... I've got a series of sequence occurring, which is good. Any questions there?
No.
No.
Why did we have to work out all from like A2 and A3?
That's just convention. You must, because what you're doing, you're trying to find a pattern. Now, a pattern could have occurred from A2, right? I mean, like I can tell the answer straight away from A2. But the idea is, anytime you want to work out a pattern, you've got to at least do 3 of them to make sure there is a pattern that is occurring, and it wasn't just by incident that it works. So you have to actually do A1, A2, A3.
Yeah.
It's convention now.
Okay.
Okay. A35. Okay. Now, there are a few things you could do here. You could either just start your sequence. So you guys can obviously see there is a sequence occurring because it's getting multiplied by 1.09. And remember, these are always going to be GPs. So always going to be this formula here for sum, because you're adding as well. Now, I mean, you could do that. What I would like you guys to see, and I think it's really important to see this for some of the harder questions, is that there's definitely a common factor in everything, right? So I'm going to be able to factorize 2,800 out. That's definitely a common factor. And 1.09 is also a common factor. So I can even factorize 1.09 out. And then what you're left with, if you can see this, if I factorize this out, I'll be left with 1 plus, this one would be 1.09 to the power of 1, so that becomes power of 2, plus 1.09 power of 2, plus ... plus 1.09 to the power of 34, because 34 plus the 1 will get me back to 35. All right, I'm going to stop there. So let me know what you guys think. I just factorized this out, and then this is what you should be left with. That makes sense to you, Alex? Yeah, that's good.
Yes, good.
Girls, all good as well?
Yep.
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 Okay, so where are we now? So now, this is where my sequence is, right? That right here. That's my sequence. This is not part of your sequence. This just stays in the outside. Now, here we go. A. What is A equal to here? Azra.
A would be 1.09.
A is your very first term.
Oh, okay, yeah, 1.
A is 1. What is R? R is your common ratio that it's going up by. Azra?
It would be going up by 1.09.
Yeah, your R is 1.09. Steph, L, can you guys all see that? Does that make sense?
Yeah.
Multiplying by 1.09.
Yep.
Cool. Okay, and then N, how many terms will you have? Again, be careful. You start from here, you're going to have 1, 2, 3, 4, all the way up to 34, but you got one more. So N is actually 35, not 34. A lot of students go for 34. They forget about this 0, extra 0 here. So 0, 34 plus 1 more, 35. All right. And then simply just plug it into our formula. So the formula is A, which is 1, open bracket, 1 minus R, so 1 minus 1.09 to the power of 35 over 1 minus R. Now it doesn't matter which one you chose. It doesn't matter if you chose R minus 1 over R minus 1 or this version. Doesn't really matter. Plug all this into your calculator. Let's do that together and hope we all get the same answer. And that's it. You would be done. Okay, I've got my answer. I'll put it here and let me know if you are not able to get this out. And just confirm if you have this.
For me, he gave it to me like with scientific notation. So
say it again, Alex.
He gave it to me with scientific notation, but he gave me like 8.48 and then times 10 to the power negative 34.
Why? Something's wrong. So are you putting it exactly as you see it here?
Yeah.
With these
Wait,
big...
I'm gonna break it up a bit.
Okay, if you want to break it up, then just do the top bit here first.
Okay.
So first do that, tell me the answer you see, and then I'll walk you through it. So the answer I see is negative 19 point blah, blah, blah. Just the top.
Wait, I'm gonna reset my calculator because this keeps on giving me like negative 2 point.
Yeah, shift 9. Shift 9. Yeah, shift 9, clear it. Clear all. Azra, do you have this? L? Steph? Anyone?
Yep.
Yep, got it.
So it's just Alex.
Wait, so in the calculator I have 1 on the outside because it's 1 times in the bracket.
Yeah, but 1 times anything is nothing, so you can completely
Yeah.
ignore it. And that's
There's
always
1
the way,
minus.
just so you guys know, the way we're doing it, our A will always be 1 because I'm always going to be factorizing it out. So this can be ignored. But anyways, we'll write 1. Yep, so 1 times.
Oh wait, no, I wrote it wrong. I put like the power to 35 for the whole bracket.
No, just this guy.
Yeah.
Did you get negative 19? Yeah.
Yeah, I got that.
Okay, and then over. Now just go divide. So just answer divide, and then brackets 1 minus 1.09. 1 minus 1.09.
Yep.
Close. You should see 215.
Yes.
And then multiply that by this, exactly as you see it, and that should be your answer.
Yeah, that's my answer.
Yeah, good. So not bad. 2,800 per year for 35 years, which is only about $54 per week. After 35 years, it turns out to be just under $660,000. So it just shows you the power of compounding. Don't underestimate compounding. It really does work. And I mean, if you just put a little bit more, of course, if you made that, let's say $100 per week, this could have been around 1.4, 1.5 million. Cool.
Yep.
Let's do
Yep.
another. That looks like the same question, so why not? An amount of $800 is invested in a super fund at the start of each year for 45 years. The fund earns 7.25% per annum compounded annually. How much is the investment worth at the end of the time? Okay, what's step 1?
We'll do A1.
A1. So Alex, you might as well do A1 together. So A1 is going to be 800, and then 1 plus
7.25.
Yep. And then I personally don't like writing it like this, so we write it more like this, 800, and then actually find this in simplified form, which is 1.0725. Okay, good job. A2, A2L. Let's do that. Let's do A2 together.
So 800 plus A1, and then you times it by 0.07.
No,
or 1.0.
1 point, yeah.
Yeah. And you just expand.
And then personally, I would not. I did it for the first one because I mean, I needed to show you guys. But the way I do it, I know A1 is this guy here, so I don't really go ahead and rewrite this in. What I would do is just go, okay, 800 times this, which is 800, 1.0725, and then when I'm looking at A1, instead of me thinking of A1, I just look at this, which is plus 800, and then this guy times this guy becomes 1.0725 power of 2. Does that make sense, El?
Yeah.
Cool. A3. Azra, tell us the answer for A3.
Be 800 bracket 1.0725.
Okay, you want to give us the whole answer, like you're finishing it off?
Yeah.
Okay, 800, 1.0725.
Plus 800 bracket 1.0725 squared.
Yeah.
Plus 800 bracket 1.0725 cubed.
Yeah. Just don't get too comfortable with that. It might not always be as simple. So just be careful. The better technique would be to know that it is 800, let's say, plus A2 multiplied by this. But for most of the questions, you're right. It's just some questions, you can't just go ahead and assume this straight away. Be careful with that. Cool. And then we need A45. Steph, A45.
So it'd be, do you need to put it in a sequence now?
Yes, correct.
So 800, then you have to put bracket 1.0725.
Yep.
And then it'd be 1 plus.
Oh no, not there yet. No way. So you got to first write your whole sequence out before getting up to that stage. So A45 becomes 800 1.0725 plus 800 1.0725 to the power of 2 plus ... plus 800 1.0725 to the power of what?
45.
45 in this case again, because if that was a 3, this was a 3. So then if this is a 45, this has to end in a 45. Okay, so you got to write that line first.
Yeah.
Now we're going to factorize. So what would you factorize now, Steph?
So you do 800 times the 1.0725,
Mm-hmm.
and then big bracket 1 plus. Would you do 1.0725 squared?
No, because to get squared, you only need one of them, because 1 times 1 plus the 1 here is going to get you the power of 2, isn't it?
Yeah.
Plus 1.0725 to the power of 44. Good job. And then hopefully last line or second last line. A, which is 1. I'll do the second version. So this one here, I did 1 minus Rn. This one I'll do Rn minus 1. So just to show you guys, it doesn't matter. R to the power of n, which again is 45, minus 1 over R minus 1. And then plug that all into your calculator and you're done as well.
Yeah, I got that.
Amazing. Now you guys have picked this up really quickly. Now I don't know, has anyone actually done this at school before?
No.
No.
Yeah, someone said yes.
Yes.
Elle, you've done it at school already?
Yeah.
Yeah, nice. But otherwise, I mean, you guys are picking up way too quickly, which is awesome. So either I'm teaching you well or you guys are just super smart. So one or the other. Series and sequence. I'll leave that for you guys. I think it's easy. Let's do some loan repayments. And then that's both of these out of the way. Okay. So I'm sure you guys can see it's broken up into 5 parts, but these 5 parts is the same as me giving you this question here and just pretty much saying, go ahead and work it out. So whatever parts are going to be given to you, you pretty much have to know it, as in if the parts weren't given to you. So just off the bat. So let's have a look at now loan repayments. Loan repayments. Okay. Can anybody tell me what the logic is for loans, I guess? How they work What's their purpose?
Borrowing money.
Borrow money. Beautiful. You usually borrow money from the bank.
You have to like
or-
repay it back.
Yeah, you've got to repay it back, right? That's the most important thing. So yes, you can borrow, 500K to buy a house, but eventually you would have to repay it. And
Is that with interest?
yeah, with a whole lot of interest. And that's pretty much how banks actually work. So the whole purpose of banks, when they were created a whole long time ago, was they're just a medium between people who have savings and people who need money to borrow houses. So what they've done is they created a medium. Those who have savings give it to the banks. The banks give these guys back a smaller return. Let's just say right now it's like almost 0%, but let's just say 3%. They give back to this person, and then this guy goes and needs to borrow money, goes to the bank again, instead of coming to this guy straight away, because this person doesn't know this person, let's say, goes to the bank. The bank uses this person's money to lend to this person here, let's call it 500K. The bank would charge this person at a higher rate because they have to give this person here, 3% return. So the bank would usually charge at least 7%. And very simply, the bank just made a 4% return on 500,000, and it wasn't even their money. It was this person's money. Does that make sense?
Yeah.
Very simple. That is actually how banks work. That is their purpose in our economy, and now obviously it's a little
Bit
bit
of a scam.
well. That's what you might hear people calling bank scams and everything like that, and it is. Look, today it's changing, especially in the era we're in. There's things called neobanks, which is completely online, so they don't have any branches or anything like that. Their returns are a lot higher, and everything actually goes directly to. So, like, if the person was getting a rate of, let's call it, was getting a return from their savings of 5%, they'll only be charging this person 6%. So they're only making the 1% to at least operate. So it's not as bad as the big banks that we have, like Combank and ANZ and everything like that. But still, there hasn't been this link between these two because of trust issues, security, and all this stuff. But I mean, it's changing. Like before, traditionally, like we're talking about 100, 200 years ago when it was first created, we didn't have the information we have today. So that's why it was working really well until all these people are starting to come up with better ideas and going, hey, look, the traditional ways of doing things has changed, and it's time to move on. So banks were created like that, and you've got to repay that amount with interest. Usually there would be loans for about 20 to 30 years, and the amount you usually pay back on an average basis is double the amount that you borrow. So if you borrow 500,000, you can expect to pay back 1 mil. So it's a lot. I don't know why I had double L, but 1 mil. So it's a fair bit, and that's when you start understanding like superannuation, you start understanding loan repayments. The best thing I can tell you is make sure you save and save as early as possible and as much as you can, because the more you can reduce how much you borrow, the better it's going to be for you long term. So instead of paying back double the amount, you might be paying back only like 650,000, let's say, which isn't bad after 20 or 30 years, when your house could have grown by, let's say, 1 million or something. Okay, so the fact that we've got to repay it as well, that needs to be taken into account in our math. And our repayments are not, hey, just repay back 1 million after 30 years. Our repayments are, you've got to pay back this much every single month. But don't forget, every month there will also be interest that's got to get added on top. So there's going to be interest that's going to be added, as well as the fact that you've got to repay every month. All right. So let's see how this one works. A loan of 140,000 is taken over 20 years. The interest rate is 12%, but it is calculated monthly. Of course it would be. With equal monthly repayments are to be paid over the life of the loan. And then pretty much we're going to calculate the repayments. That's what we would like to work out. Calculate your repayments. Calculate your repayments, that's it. Each of your monthly repayments. Okay. A1. Okay, anybody know what A1 would be? It definitely is 140,000. Alex, you want to say it?
No, I was just gonna say we start with 140,000.
Yeah, okay, good. We start off with 140,000, that's fine. Bracket, that's gonna, look, think about it again. You got 140,000 in your bank now, right? In your bank account, right, Alex?
Yep.
But they're not just going to allow you to give you 140,000. They're going to do what straight away after the first month?
They're gonna give you they'll make you pay something back.
Yeah, but before that, they're going to first charge you what?
Oh, with the interest rate.
They're going to charge you interest, right? But the interest is done monthly. So 1 plus 12% over 12. So my R is 12% over 12, which 12% over 12 should become 0.01. Can you see that that's working out? After your first month, you got 140,000. That grew for this much, and then what must happen at the end of the month?
Minus
Mine is your repayment. You must pay back some money.
Yeah.
Does that make sense, Alex? They gave you 140K. Because they gave you 140K, they're going to charge you interest. But then the amount remaining after the first month, because we're doing things with months now, is the amount that you borrowed plus the amount of interest that they charged you, take away anything you repaid back.
Oh, yeah.
Cool?
Yes.
Okay. I'm just going to rewrite that a little bit neater. 1.01 minus Azra, Steph, that makes sense as well.
Yeah.
Okay. A2. Steph, let's try A2 together.
Okay.
So think of A2 like this. So this is the amount of money you got left at the end of the first month, right? Whatever that amount is. We don't know. We're going to try to work out what R is soon. A2. You know A2 is going to be the amount you had left in A1, right?
Yeah.
That's going to grow for 1.01. Because are you going to add money on top of A2? So it's not like superannuation where we're adding money.
No.
Right? What's going to happen is you're going to have the amount you had left in A1. That's going to grow. And then you're going to subtract what at the end of it?
Repayment.
Your repayment. And then A1 is all this. And then expand. Steph, just have a quick look at that. See if it makes full sense to you. And you can see you're in your second month, so your loan would have grown for 2 months. Which kind of makes sense as well.
Yep.
But then minus your repayments that you've made. Okay. Do you understand why, just before you go, do you understand why I also said not to add or subtract anything to A1?
Yeah.
Yeah.
Yeah. You'd have
Think
to
of it like this.
times it.
Think of it like this. This is end of January, right? End of January. Now, what happens at the beginning of February? Well, beginning of February would be the exact same as end of January, right?
Yep. Yeah.
So, beginning of Feb, which is the second month, is the same as end of Jan, so A1. Then at the end of February, it would have grown for 1.01. And then just before the end of February, what must we do? Make our repayment. Minus R. And that's the math.
Okay.
So A3 is going to become A2 times 1.01. And then again, minus R. A2 is all of this. So that becomes 140,000. 1.01 cubed minus R 1.01 squared minus R times 1.01 minus the R that I have here. Any questions?
Nope.
Girls, any problems?
No.
Okay, done. Then this is not part of your sequence because obviously it doesn't have any R's occurring. So this is going to be by itself. This will have a sequence. So the sequences will occur with the ones that are with R's. Now, again, can you see how this one's decreasing? I said I don't really like it decreasing because you'll get your sequences wrong. I can promise you. So what we're going to do is just learn to rewrite this one as an increasing one. So I'm just going to rearrange. There it is. I haven't done anything. I'm just rearranging so that we can learn to always increase in value instead of decrease. Okay. Dot, dot, dot. A. Okay. Remember, this was for months. So if it's 20 years, how many months will I have in 20 years? Well, 20 times 12, 240 months. Okay. Azra, let's do this one. When you're trying to write your sequence here, you're going to follow your A3. So A3 became 3, and then the last one was 2. So Azra, A240, what are you going to write? Must equal to?
A3 or other.
No. So A240 is going to equal to?
140,000.
And then 1.01
01.
to the power of?
3.
No. So this was 3, it became 3. This is 240 now.
So that would be 240.
Yep. Minus R 1.01 minus R 1.01 squared. Oh, sorry, not plus. Minus dot 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 minus R 1.01 to the power of what? Confused?
Mm-hmm.
Well, look, what does this say?
3.
And then what does this say?
3.
And what does this say?
2.
So
So
what?
it's 239.
That's the idea. So that's how you're looking at this. So this is a 3, this is a 3, so therefore this is 240 because it's 240. your last number is a 2, and that's why I told you guys to rewrite this as increasing powers instead of decreasing powers, so you can tell. Okay, next line. Again, I'm going to factorize r out. That's the only thing that's common. So I'll get r out, and then you're left with 1 plus 1.01 plus 1.01 squared plus at the top plus 1.01 to the power of 239. Any questions, you guys?
No.
Next line equals 140,000 minus R. All right, A. A is 1 again, isn't it? My R, my common ratio, it's going up by 1.01. And to the power of what? How many terms am I going to have? My last one's 239. How many terms will I have?
240.
You will still have 240 because of this extra 1 here, right?
Yeah.
Minus 1 over R minus 1. Okay. Now, we're literally almost there. You can see the problem is I've got 2 unknowns. I've got A is 240, and I've got, that's unknown, and I've got R, that's unknown. The question was to solve for R. So somehow this guy's got to disappear. What do we know the amount after 240 months is going to be? What will the amount be after 240 months? Again, think about what's happening. You're borrowing money and you're repaying it, and then time goes on and on and on. What's the answer to A? 240. What must that equal to? Anyone want to take a guess?
Do we go on another month or something like that?
No. It's an actual number. What would be the amount after 240 months?
140,000. And this like 0.101.
What's the amount remaining after 240 months? Maybe I should say that. No, still can't do it. Girls?
I don't know.
I guess would probably be right. Yeah, you do. The amount after 240 months. Steph, what's happening here? So what are you borrowing? How much are you borrowing?
140,000.
Okay, and then it's growing, and then you're repaying back. And then it's growing, and you're repaying back. Second month, third month, it's growing a little bit more, you're repaying back. But eventually, what would the amount be equal to after you finish repaying everything?
Would it be?
What would the amount be after you pay back everything?
Is it doubled?
Well, no. If
Is it 0?
Isn't it 0? Yeah. Isn't the whole point that you're trying to repay your loan plus the interest? So the amount remaining after 240 months should be 0.
0.
And then, simple, you're just solving for R. Now, I'll show you the way I would personally do this. I don't want to rewrite that all again. The math is fairly straightforward. You would have plus this all over to one side, and then it would have been this answer divided by this answer. So R, and I think you guys can understand what I'm about to say here, R would be this term. We're going to call A. I'm going to say this is B. If you do your equations, it's just going to be A over B. So does everybody get what I've done there? Imagine this was a number, I've just plussed it over, and then technically to solve for R, you're just dividing it by B.
Oh, yeah.
So let's see if we can all get the same answer now. Plug it into our calculator. Be careful when you're doing B. I'm doing it separately. I'm doing it all in one go. I worked out my answer.
Got it.
Nice.
Is that per month? Like how much you have to pay?
Yes, correct. So as long as you pay $1,541.52 per month for 20 years, you would have paid back your $140,000 plus all the interest they would have charged you.
Yeah, I got it.
So that is exactly, that's exactly what the bank will do. The first day you're going to borrow money, they're going to literally, I mean, obviously a computer will do it now, but they'll literally give you this answer. They'll give you this number and say, okay, if your loan's going to go for 20 years, then you must pay us back this amount right now, every month. And then the idea is after 20 years, you would have finished it off. Obviously, if you pay more, you pay it off earlier, right? Okay. Let's recap that one. Do you feel like this was a bit harder than the superannuation one? Or same?
Just a little bit more tricky, I think.
Yeah. Harder, a little bit.
A1, the amount you borrowed times the rate minus your repayment. A2, the amount left times the increase minus your repayment. A3, the amount left in A2 times the increase minus the repayment. And then we always increase in powers, so don't decrease. So your last line for A3 before you do your A240 is to increase it. Then you just look at your powers. The first one's going to be 3 and a 3, so 240 and 240. The last one ends in a 2, so that means, and if it was a 3, so that means if it's 240, it has to end in 239. Again, we factorize the R. In this case, 1.01 wasn't a common factor, so I didn't take it out. I just took out R. And then, of course, because they're all subtraction signs, and I took out a negative, these all become positive signs. And then that just becomes a series. And then I think this one, most students just memorize that it's got to be A over B, because it's really easy to do it like that. But if you wanted to do the actual math, you want to plus this all over and then divide it, it works the same way. All right. Let's try to do this one. I'll let you guys try to do A1, A2, and A3 first. Actually, I'll do A1. I'll let you guys do A2 and A3. Okay. A1 would be Murray borrows $30,000 at 6% per annum, reducible interest, which always is, paying it off in equal monthly installments, calculate the amount of installments she wishes to have the loan paid off after. Excuse me. 4 years. So 4 years would be 4 times 12, 48 months. R equals to 6% divided by 12, which is 0.005, which means my 1 plus R is 1.005. So my A1 is 30,000. How much I borrowed? They're going to charge me some interest, and then I've got to pay back an amount, which we're labeling as R for now. If that makes sense, please move on to A2 and A3. Okay, L, what's A2 equal to?
30,000 bracket 1.005 what's the power to minus R bracket 1.005 then it's R.
Beautiful. So pretty much you just did A1 times by the interest rate minus R and then expanded. The others, you all got that? You're all happy with that line?
Yep.
Yes.
Yeah.
Cool. Cool. Wow. A3. A3. Yep, all good with that?
Yep.
All right,
Yep.
before I do A48, I just want to do something a little bit different. I want to say if it was A-N, so any number, I don't mind, like even if it's not 48. I just want to make sure we really get this. So if it was A-N, Alex, what would you write? A-N equals 30,000, bracket,
1.005, and then to power n.
minus R, 1 plus 1.005 plus 1.005 squared plus dot 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 plus 1.005 to the power of,
n minus 1.
good man. Okay, let's keep going. Let's still deal with n's. A, what's your first term of your sequence? A, 1.
1.
R, and then how many expressions do you have now? So how many terms do you have?
We have n minus 1.
No. See, remember it starts from here, n minus 1 starting from here, right? 1, 2, 3, 4, all the way up to n minus 1. You're going to add one more because this one here is not part of your sequence. Unfortunately, these powers won't work exactly like that. Do you get me? It's like that zero case that we were talking about before. So
Yeah,
like
yeah.
from 1, it'll be 1, 2, 3, but you're not starting from 1, you're starting from 0.
Yep.
How many numbers are there from 0 to 1?
2.
Yeah, there's actually 2 numbers, and that's the problem. So it's not just 1.
Yeah.
So if it's from 0 to n minus 1, it's n minus 1 plus 1, which becomes n. And then minus 1. Sounds good?
Yep.
And then, of course, if you guys know how to do that, then no matter what I give you, A200 and, I don't know, what was this? Not 200, 48. If I gave you A48, then the answer is always just going to be very simple. Look, 30,000, plug it in for n. 48 minus R, 1.005, 48, minus 1 over. And then again, what does A48 equal to? 0, because the whole idea is up to 48 months you would have had to repay back the whole loan plus the interest. So R equals 30,000 over this month's sticking. Let me know if you guys have any questions for that one. All right, I think I got my answer. $704.55.
Yeah, I got that.
Awesome. Girls, we're all happy with this?
Yeah.
Yep, got it.
Done. What I might do, I know, Azra, you had a question about rates. What I might do is just start on that with you, and then there at U3, I'll send you a question to do. Let me just have a quick look at it. Yeah, done. I'm happy with that. So close that. Did I write on this? Oh yeah, just that bit, but I think that's easy. You guys more want the second booklet. So I'll send you that. Discard. Save this. So far, Tuesday, U12. Save. Once we finish the chat, I'll actually send you everything.
Okay.
This should be a familiar book for you guys. Superannuation, so this is a straight HSC question. Yeah, simple. Question 1. Save, and then I'm going to send it to our group chat, which you have access right there. Oops. You guys should get that now.
Yep, got it.
Yep. All right. Start that question, please. Azra, let's start your ratios and rates real quick. New document. Okay, Ezra, have a look. So, okay. Ezra, the first thing you need to know is that a rate is just differentiation, right? So it's just dy on dx. The thing is, if it's going to be a rate, it usually is going to be in terms of t. So it will be like, you know, dx on dt or dv on dt. The best way to look at it, and the trick to it is, if you've got something that says meters per second, meters would be 1 unit, which would be like, let's just call it if it was meters, we're looking at distance. So x is usually representing distance, and s, which is per second, represents time. In this case, it says like centimeters squared per second. That means d of the area over dt. Does that make sense firstly?
Yeah.
Okay, so it says the rate of an increase of a circle's radius. So therefore, straight away, I'm already thinking dr on dt is equal to 0.2. Did you know that before we started this?
Sort of.
So you kind of knew that's how you read them, okay?
Yeah.
Fair enough then. And then at what rate is its area increasing when the radius? So the idea is now you're trying to work out the rate of the area. So you're trying to work out dA on dt. Cool? To work out dA on dt, the way we write them is dA on something times something on dt. As long as these two are the same, can you see I'm allowed to actually write it like this? Because imagine this was like x and x, I can cross them out and they become the same thing and I get dA on dt. Okay. The trick is these two are going to be dRs because you were given dr. Any questions yet?
No.
Again, is this the bits you were having problems with, or no, it's something else?
I think it was this part.
It was this part, yeah. So I thought so. dr on dt pretty much becomes what, 0.2, but dA on dr you don't have, right? Like, what is dA on dr? That doesn't make any sense. So what you need to understand is you have to go and create an equation with a and r, and it's a circle. So obviously, what are you going to write? A equals
Pi r squared.
pi r squared. Now you're not meant to sub in 1.5, because if you always sub in your answer straight away, you're going to differentiate it. It's always going to be a constant because you've got rid of your r. So the first thing you're meant to do is go dA on dr, and that just becomes 2 pi r, which is circumference. And then now you can go and sub in 1.5, for example. So 2 times 1.5, which becomes 3 pi. Now you know what dA on dr is. So dA on dt becomes dA on dr, which is 3 pi, times 0.2. Do you fully get that?
Yeah.
Be careful. You see this bit here? It says dA on dr. Don't think it will always be dA on dr. You could have had dr on dA, but you can't do dr on dA. You're still meant to do dA on dr and then just flip it, right? That becomes 1 over.
Yeah.
Understand that? Beautiful. Okay. And another thing is, if you had, let's say, dA on dV, because this will happen with some of the questions I've got here, dA on dV. Can you do area in terms of volume? Probably not, yeah? Do you know an equation with area in terms of volume?
No.
No, I didn't think so. So if I was to do this, dA on dV times dV on dt, they usually tell you, volume in terms of time. So let's just say water coming out of a tap, something like that, and how much it's filling up. So that would be volume. dA on dV itself has another rate that you have to split that up. So let's just say dA on dr times dr on dV times dV on dt. Do you get that?
Yeah.
All right. So I'm assuming if all of that makes sense, then if I quickly jump into question 4, and if this one makes sense, then we'll just go back to the serious stuff, and I feel like you can do it now. Unless you want to try it for the next, I don't know, half an hour or whatever. You want to do some of these questions, just make sure that you do fully get it. Well, let's have a quick look at this. A conical vessel is 40 centimeters in radius and 40 centimeters in depth. The vessel is being filled with liquid at a constant rate of 24 centimeters cubed per second. So straight away when I see that, I go dV on dt equals 24, because volume cubed. The depth of the liquid at time is h. All right, what is the rate of increase of the surface area? So what are we trying to find? dA on dt. You agree with that?
Yeah.
And then it does say, find the surface area of a cone when it's this. I think you understand to do this, you're going to split it up with dA on something times something on dt. The letter that was given was dV, and that's dV. But as I said to you before, you don't have a relationship between A and V, so you're probably going to split up dA on dV to dA on dr times dr on dV. What's area in terms of radius? Well, the height and the radius are the same. So this A equals pi r squared plus pi r h. Yeah, r equals h because the radius equals to the height. So therefore your area just becomes pi r squared plus pi r squared, which is 2 pi r squared. Does that make sense, Azra?
Yeah.
And then you get dA on dr becomes 4 pi r. And then how do we find dr on dV? Well, again, V equals to, it's a cone, so V equals to 1/3 pi r squared h. Yeah, pi r squared h times a third. That's the volume of a cone. Again, h is equal to r, so that just becomes r cubed, get rid of it, and then dV on dr. Can I assume that you can do the rest? Times 3 pi r squared, and then dr on dV, because you found dV on dr on dV is 1 on pi r squared. And then plug that into this bit, plug dA on dr into this bit, now you just found dA on dV times dV on dt. So follow the answers that I've sent you. Do you have access to the full booklet?
Yeah, I printed it out.
Yeah. Go through it, see if all that makes sense. If it does, then perfect. I just realized the mistake I did here as I was rushing through this. This was actually meant to be L. I was like, oh, why did I write L when it's H? Surface area is a slant height, yeah?
Yeah.
So you're trying to work out L. L is Pythagoras to find your relationship. So L is a slant height. So L squared is equal to R squared plus H squared. And then like I was saying, R is equal to H. So L is equal to root 2R. And then you're meant to differentiate that. But that still happens, what I was just saying to you before. dA on dr times dr on dV. Okay, try that. I'll just check on the others. You guys, how'd you go with this HSC question?
All right.
It was alright.
Yeah.
think I got it.
Yeah, you think you all right? Well,
Same.
okay, let's have a quick look. Solutions. L, are you done as well? L, are you there? Page number 29. Is L there? What's happening? L, can you hear me? Everybody else, can you guys hear me?
Yeah.
Okay.
Yeah.
Yes, yes.
Oh, L, yes, you're back.
Yeah.
299,000. Did you guys get that, Alex? Steph, is that what you got, or not really?
No, I didn't get that.
No, I didn't get that either.
Oh, well, what did you guys get? Maybe you guys got the same answer. What did you get?
Oh,
I
wait,
got
why is it 21?
200.
All right, let's read. L, did you get it out or not really?
No, not really.
Okay, let's have a look at the first three lines. Do we agree with that?
Oh,
Yeah.
yeah.
Okay. Right, I think I feel like I know where you guys went wrong. At the beginning of each year, 1st of January to 31st of January 2023, how many years did you guys use?
20.
Yeah, that would not be right. 1st of January to the 1st of January 2023 is how many years?
20.
Yeah.
20.
So 31st of December 2023, technically, it's the 1st of January 2024.
Mhm.
Does that make sense?
So we have to use 21
So you're
years.
using 21 years, yeah. Because it went for another whole year. Like if it's the 31st of December, the year started at the beginning of January, you still get money from all the way from 1st to the 31st of
Yeah.
that year.
Oh, okay.
Yeah, I'm guessing then you guys got everything else right. It's just this you wrote
Yeah.
when
Yeah.
you. Okay, fair enough. Well, that's not too bad. That's an easy fix. Well, there you go. 4 marks in the HSC, you guys. That's pretty good. And like I said, this will be at the end of the paper. Let's do another one. Let's do a loan repayment question now. So be careful, your loan repayments, you gotta have your minus R happening. Next question. Azra, how are you going with those questions?
I haven't gone on to the next one yet.
All right, wait, let me open up your textbook as well and see some of the questions you were doing. So, year 11, right? You said, sorry?
Yeah, year 11.
Year 11 textbooks. That's in focus. And which one? Introduction to Calculus?
This book's Cambridge.
Oh, sorry. Cambridge. What chapter?
16.
16. Further rates. Okay, and what exercise?
The first one.
Right. Okay. Read this. Use the chain rule to find dv on dt as a function of r and dr on dt. Yeah, it's literally what I was just telling you. So instead of, I don't use the words, these words are confusing for everybody. dv on dt can be written as dv on something times something on dt. If you know it says dr, then therefore you know that these two are going to be drs. Yeah?
Yep.
And you know it's a sphere, so v equals 4 on 3 pi r cubed, which means dv on dr becomes 4 pi r squared. And then, I mean, pretty much this is literally what we have actually. Suppose that the flow rate is constant. If it says 50 centimeters cubed per second, what do you know straight away? 50 centimeters, that's what,
dr on dt.
not dv on dt, because
On
centimeters cubed. So, there it is. dv on dt is 50, and the radius is 7. Why? Because it says the radius is 7. At what rate is the radius increasing? So we need to find dr on dt. Well, you have this expression, you already know what dv on dt is, you just solve for dr on dt. Divide everything. I think it kind of, does it make a bit more sense?
Yeah.
And it just keeps happening over and over again. You do need to know your formulas for everything, but I mean, like dv on dt again is dv on dh times dh on dt. Why did they pick h? Must have been in the question here. The height. Find the rate at which the height is changing. So you need to find dh on dt. So me personally, just so you know the difference between the way I've been doing it, I didn't start with dv on dt. I actually start with dh on dt. So if the question says find the rate of the height, which means dh on dt, I'm already thinking dh on dt must equal to dh on something times something on dt. And then if it says meters cubed here, I know this is going to be dv and dv. Yeah, Ezra, does that make sense?
Yep.
Are you going to do those? Are you going to do some of the questions, or are you going to do series?
Yeah, I might do a couple.
Yeah, do a couple. Probably from my booklet, it might make a bit more sense. It's a bit more structured first, and then come back to it. You guys, loan repayments, example 33. Have we finished it yet?
Not
No,
yet.
I haven't.
No.
Okay, let's just make sure we're on the right track. Here you go, it's on the screen. 8,000, 1 point, okay, it says it's already 1.6% per month. I hope you didn't divide it. Did you guys divide it by 12?
No.
No.
Okay, that's good. Otherwise, yeah, that's already per month, so you didn't need to. And yeah, you just do your math. So hopefully you have A3 out. I'll leave it with you. To there, I guess. I don't write it like this. I write it increasing in powers, right? That's what we said. So You guys, you done? Did you guys get an answer of $240.05?
I'm just putting in my calculator.
Okay, nice.
Yeah, so
I got it.
Yeah?
Yeah.
Same answer. Great work, El.
Yep, I got it.
Nice. And then Alex last one, I guess. Ezra, how you going with your calculus stuff?
yeah, I got
Pretty
it.
good.
Okay, good. Alex done. Good. Good. I did tell you, Ezra, for this, it'll take me 5 minutes, right? I did it super quick, but I think it all made sense. If you just know that trick that I just told you here, that these two cancel out, something that's super complicated becomes okay. And actually, Ezra, the trick is also the fact that, yeah, you're meant to look at this rate, millimeters per second and centimeters squared per second. It tells you the answer. So I know that's area, I know that's volume, I know that's just normal distance. So, okay. You guys, let me see. Find a formula. Peter chooses. Still a little bit. I'm going to try to take it up a notch. A store offers a loan of $5,000 which charges interest at rate 1% per month. A special deal store does not charge interest for the first 3 months. However, the first repayment is due at the end of the first month. Interesting. Okay. This is, yep. This is for you guys. I'll take a photo again. It's worth 6 marks. It's been broken down. I just want your answer for the first one. Just I. Let's see if we can get I out. I will talk about it with you right now so you can understand the logic behind it. Okay. Where are we? Okay. What happens in this case? So have a quick read. A store offers a loan of 5K on a computer for which it charges interest at the rate of 1% per month. As a special deal, the store does not charge interest for the first 3 months. However, the first repayment is due at the end of the first month. So what would A1 be? Alex, do you feel like you kind of understand the logic of what A1 should be? Or not really?
I don't know. I thought I had it, but not anymore.
Just say it. Just say. What would you say for A1?
Wait, so would it literally like it's like normal A1, but like then we take away that? I can't explain that. Not too sure.
Well, okay. If it's interest free, right? You're not getting charged interest for the first 3 months. So in that first month, are you going to multiply by interest?
No, so would it just be like 5,000 minus R?
Yeah, that's exactly what it is. In this case, it just says repayments are M. But if you choose R, just think about it. These are all going to be R's. But yeah, it is. It's exactly what you just said. It's just 5,000 minus R. You're not getting charged any interest. Don't forget that. Girls, does that make sense as well?
Yeah.
Yeah.
But you still have to make your first repayment at the end of the first month. So you still got to pay R. They're not just going to allow you to make no repayments and no interest. That's way too good.
Sam,
Yes.
I'm not really getting it.
Do you firstly get A1 or not?
Yeah.
Okay. What's A2?
Would I still do A1 times 1%?
No, you can't because it's still interest free, isn't it?
For the
Aren't-
first 3 months.
Yeah, for the first 3 months. So am I meant to get charged interest in the second month?
No.
Isn't it just going to be A1 minus another repayment?
It's the same thing. Oh, 2R.
Well, because you've got minus R already.
Yeah.
And then what should A3 be?
It'll be 5,000 minus 3R.
I'm very hesitant making you guys, and that's what I was trying to say before. I'm not really interested in the formula. I mean, I'm not interested in the answer at the end. I'm more interested in this logic, like these steps, more than this step. This step's easy. I just need you to understand to do A3, it should be the amount you have left from A2 minus any repayment. And then, of course, it does become. So, yeah. Double I, please do it again. Show that A5. So now you're going to do A4. So what happens in A4?
You have to charge interest.
You're going to charge interest. That's going to be A3, charging interest. So 1 point, what is it? 1% you said? What was it? 1% per month. Yeah. So 1.1% per month. So that should be 1%. Would be 0.1, yeah. And then minus what? Anyways, minus what? Just quickly. And if you're wondering like where 1.01 comes from, you know it's a show question, so they've pretty much told you it anyways. Okay. And then once you do A4, you got to do A5. So expand that, and then hopefully you would have found what was required. Okay. Were you able to get A5 out, or still?
I think I got it.
Let's say 5,000 minus this minus that. Just leave that over there. And A5 becomes A4 times minus A4 is 5,000 minus 3R times by 1.01 squared minus r times 1.01 minus r. And I think that was what we wanted. They just want you to factorize it out. Alex, you think you got it out?
Yeah.
Yeah, I had mine expanded there.
Nice. Elle, you got it out as well. That's great. Yeah, you can't have, if you had expanded, it's fine. You got to go back to factorizing because it is a show question. Steph, is this making sense or?
Yeah, I just got confused, like
With-
writing A5 out. So I got A4,
Yes.
just
Yeah.
not A5.
Well, A5, I'm kind of cheating. I know the answer. So I know this is meant to be factorized. I mean, this is not meant to be expanded. It's meant to be factorized. But usually we've been expanding it, but this is telling me not to expand it. So therefore, I didn't bother expanding it. I just went, okay, A4 is that. This times this becomes squared. R times 1.01 is R 1.01, and then just minus R again. And then just says factorize. Okay, now final expression for A36. Let's see if you guys can get that out. I'll leave that with you. Azra, any questions?
5A I'm stuck on.
Question 5A. This one here, the part of the curve.
Yeah.
The part of the curve of x squared equals 32y between y equals 0 and y equals h is rotated at the y-axis. Show the volume of solid generated is given by this. Right, because you've got to actually do integration. We haven't done volumes like that yet. Oh no, we did. No, we did. Remember volume equals pi times pi from, let's just say in this case, it's from 0 to h. It's the y value, and you've got to use x squared dy. Does that ring a bell?
Yeah.
So the formula was for, like, if you were doing volume of your x, it's pi ab x squared dy, and if it was of your y values, sorry, y squared dx, and if it was y, the answer would be pi ab x squared dy, and then we said we have to make x the subject and sub it in, whereas this one you got to make y the subject and sub it in. Does that kind of ring a bell? Or not really? Yeah, it does. Okay, then x squared is what, 32y? And then that's it, really. So 32 on 2 is 16. I think you can tell the answer is going to become 16 pi h squared. From 0 to h because it's the y values. Cool?
Yep.
All right. Okay. Alex, you want to give it a shot? A36.
Okay.
5,000 minus 3r, 1.01 to the power of.
33.
So when it was 5, it was 2, which is 3 less. 3 less than 36. 33. Good job. Minus r1 plus 1.01 plus 1.01 squared plus dot 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 plus what's going to be the last one?
35.
Nope. L, do you know it? Do you know what the last one should be?
32.
Correct. So the way you look at it is if this is a 5, this was a 2, this was a 1. So it's going to be 1 less
Oh, okay.
than the 33, I guess. You chose 33, it's going to be 32. Or the way I look at it, that's a 5, that's a 1, that's a difference of 4. So 36, take away 4, 32.
Yep.
Okay, you got to remember, you got to always compare it like that.
Okay.
All right. And that is A36. Is that what he said? Yep, final expression, you're done. So pretty much you guys are, at this point in time, if you're able to do all that, you're at 4 out of 6.
Okay.
You just need the last one, which is to find M, or R in this case. To do that, don't forget A36 is 0. I'm just going to rewrite that. Actually, we can just create a next page. Page and then page. There we go. Don't forget, make that equal to 0. And this time you probably need to expand because you can only have one R when you're solving, right? So you're going to make R the subject. You'll probably have to change this bit to your series, and then we'll wrap it up.
Okay.
So actually, I'll do it with you guys. Here we go. I'm just going to make this a bit larger. All right, A36 is 0. 5,000 times 1.01 to the power of 33 minus 3R times 1.01 to the power of 33 minus R times A, which is 1, R to the power of N is going to be 33, take away 1 over R minus 1. Any questions, Steph? Any questions there?
No.
No, I just expanded. That kind of made sense.
Yeah.
Yeah, go ahead.
So you removed the 5,000. Not the 5,000. The 3R from the bracket.
3R times this. There it is. And then minus R times this.
Okay.
Then usually you would bring your R's to one side.
Yep.
So R, and then you know you can't have two R's. So what would you usually do? You would factorize your R out, yeah? So let's see if you guys can do this in one side, in one line. I'm going to plus it over, so I brought it here, and I'm also going to factorize my R out. It's up to you and your math. I mean, some of my students have in the past said, well, that's too hard. What I would rather do is just work out what this is as a number and what this is, and just, subtract them or add them accordingly, and then divide. It's up to you and your math. I just got to show it to you like this. Does it make sense what I've done here to everybody?
Yep.
Yes.
Okay, fair enough. So I plus that over, and then I just factorize R. And I think you know what I'm about to do. I'm going to go this. I'm not going to rewrite it. It's a bit silly. That's A. That's B. You're literally just going to do A divided by B. And then the answer you should get, we can cheat a little bit. The answer you're going to get is $161.34. So you can see here, I did do it that way. I split it up into two different numbers and then just put it all together. It might be a little bit easier to work with, but again, some of the harder questions requires your algebraic skills to be as good as what I just did, which we'll look at them next week. So again, the answer is $161.34. Do we have any questions for that?
No.
Okay. If you've got any questions and you want to stay back for any of your topics or anything like that, you can. I'm going to, as soon as I'm going to press